my gosh. All right, so a few more people just came in. Are there any other questions from the homework stuff or just general questions? You guys doing all right? Anybody else freaking out about today? Or is everybody just trying to forget? And I'm sorry I brought it up. Okay, all right, we're gonna make it. So, all right, good. That's a good place to start. So I'm gonna propose something about this next quiz. Here's what I propose about the next quiz. Currently, the quiz is officially scheduled for this Thursday. Now, the last quiz, we had to push it back a little bit. So I'm gonna propose that we push this next quiz. Let me put it up here so you guys can see. Pop. So currently, this next quiz is scheduled for Thursday, right? And there's a couple things wrong with that. This Thursday, I have that big old meeting, so we're not going to have class on Thursday in the first place. But also, we're definitely not quite ready for all that stuff. So I have two things. I want to make this become a Monday quiz. What day is Monday? The 9th. And it's going to cover, remember the last quiz went up to 3-3. So we'll do 3-4 up to 3-7. I'd be a little surprised if anybody has a problem with that, but is everybody cool with that? Anybody have any questions about that? I do need to update this homework sheet. Someday I'll do that because the last bit here is going to be a little bit shifted. So I'll see if I can do that. Okay, so next quiz will be Monday, the 9th, and it'll cover 3-4 through 3-7. Cool. I like it. All right, just make sure everybody sees that. Any other questions? So that was a question about the quiz. Any other questions, guys, about homework or anything else? Okay. All right. What I want to do first is just just a kind of a little review. I know we did a bit of a review yesterday, but especially with that formula we just learned yesterday, and that was the second formula for the equation of a line. Let me spotlight me, so it's all about me. There we go. Me. All right. What's currently on my board is some trigonometry from last night. Yeah. Crazy party times. All right, so let me take this away. So we've got two equations for a line. This is the one we've been working with for a while. This guy. Let me straighten my room out a little bit. Come on, room. All right. And then we just learned this guy. I like it. Now, of course, what does M mean in both of those? In both of these equations, what is slope? Somebody remind me, in this equation, what does B represent?
Y.
What's that?
Yeah, it's the Y piece of the Y-intercept, right? I like it. So this is old news. We've been working with an MX plus B for a while. This is the new one here. So M obviously still means slope. What is X1 and Y1? What are those? Is anyone?
Points on the graph.
Yeah, it's just some point. A point on the line. Could be any point. You make this look more like a 1 and more like a comma. All right, so I want to do a different kind of example than the one we did yesterday, and then we'll do an example like yesterday, and then we'll get into some new stuff. What we're going to do today is talk about a statistical use of lines, right? So it's kind of nice to see an application of these lines to see what the hell they're used for. Okay. So let me do this. So everybody got what they want from that. This is old news. We know all this stuff here. I like it. I'm going to erase this bad boy. So if I give you this equation right here, see if you guys can tell me. Take a minute. Don't say anything. Figure out what the slope is and figure out what a point that the line goes through. Don't say anything out loud. Try to figure out those two things. All right, so who's got the slope? What's the slope?
-2.
Yeah, why? Because it's in the right place. Now here's something interesting. What is the point that I can see this line goes through? Somebody else.
Four.
Can I guess?
So that's a part. Again, sorry.
It would be 4 and -5.
No. No. So let me remind you guys, here's the equation of the line. So what is the x piece? What's x1? What's the x piece?
Five.
Yes, not -5, right? Because here's the equation, x minus this. So whatever is here is the x piece. Now what's the y piece?
5.
No, that's the x piece. What's the y piece?
4.
Four.
-4.
Whatever, no. Y minus the y piece. So y minus 4. All right, let me stop for a minute. This is kind of like a gentle introduction of something we sort of looked at before, how to correctly use forms of things. So whatever number is here is the x piece, and whatever number is here is the y piece. Let me do this. Is that better right now? I mean, if I give you an equation, you just have to pick out the parts and put them in the right place to tell me stuff. Let me do a problem like this. All right. Let me see. Do I have enough room for this? Yes, maybe. What if I told you that the slope is 7 and the point it goes through is -1, 2? Can you put the line equation together? So you can identify these for yourself. We know the slope is m. I can call this the x piece of the point and the y piece of the point. So what happens when you throw that stuff in? What goes here?
2.
2. I like it. Now what goes here, of course?
7.
7. And then what goes here?
-1.
Good. So what's going to happen if I clean this up just a little bit, what happens inside here?
It returns to positive.
Yeah. Minus and negative is plus 11. So what point does this go through? -1, 2. Because there has to be a -1 there. That's why it's plus. Whoa, am I laggy? I checked my Wi-Fi this morning. That's all hope. All right. So let me see. Let me try another problem out. Find an equation like this here. The slope would be 1/4, because that's where m is. That's the 1/4. And the point would be 5. But what am I going to put here for the y piece?
Three.
-3.
-3. Because remember, the equation is y minus the y piece. Right? So if there's a positive number, if this is plus something, what must I have put here to make this become plus? I must have put a -3. Then it would become minus and negative is plus. All right, so that's the one little thing you gotta be careful about. In the general form of the line, there's a minus sign. If I see a plus sign, that must mean the value was itself negative. That's the only way it could change to plus. I like it. So it's not crazy hard. It's just something we're not used to thinking about. Okay. Now, let me create a problem more like what we did yesterday. Do you guys remember, all right, let me take this away. Do you guys remember how parallel lines are related to each other? How are the slopes of two parallel lines related?
They're the same.
They're the same, I love it. Now think about that. Two parallel lines have the same slope. I love it, I love it. So what if I told you this? Find the equation of the line going through. What do you got, Jeff? 4, -7, and parallel to, what do you got, Jeff? I don't know. 2x plus 11. I like it. Who remembers the two things I need for the equation of a line? I definitely need what? Slope. And what else?
Any point on the line.
Any point, kick ass. Now this I know, this they tell me directly. Yay, I got a point. Every now and again, I got a point. What is the slope of my line? What's the slope of the line I'm trying to figure out?
2.
Yes, because my line is parallel to this line. And what is this guy's slope? His slope is 2 because that's in the right place. So then therefore, my slope has to be 2 because they're parallel. All right, now take a minute, put the equation together and solve it for y like we did yesterday. Whoa, I'm sorry, Andrew, I'm totally missing all your chat. That sounds familiar. Yeah, I told you guys, when I'm up here at the board, I'm not looking at chat. You gotta like, just talk to me. If you can. I think you're not, you're micless. I'm sorry, Andrew. I like it. So let's see what's going to go here. Say again, sorry.
I said +7.
Yeah, because it's going to be a -7. So negative negative makes +7. And of course, m is 2. And what goes here?
4.
Yeah, the x piece. So the x piece and the y piece. All right. You guys doing okay out there? And remember, if you can turn on your camera, that'd be much appreciated because it helps my mental health to see people. I know some of you can't at the moment. And then if I want to solve this for y, this should be the semi-easy part. There's Riley doing class right out in the real world.
I had to drop off my car.
Understood. All right, so that should maybe be the easiest part for us because we've been solving equations for a while. Okay. Now, so that's kind of like up to date. We're up to date with where we are with lines. We know 2 equations of lines. So now I want to transition into an application of lines. My incredibly smooth transitions between multimedia experiences. Hold on. Oh, here we go. Okay. There it is. So take a look at this. So we've graphed scatter plots before. Remember those? We would just plot points. So these are 3 different graphs. What is the x-axis? What is the y-axis? We're going to worry about that in a bit. This problem, I just want to talk about which one seems to have a positive trend. And I'm not even going to explain what that is. What's your gut tell you? Sorry.
The first one?
Yeah, and in this case, the idea, have you guys heard of the trend line? A trend line? Even if you've never heard of it, it might maybe make sense. If I were to, of course, Jeff, let me switch my technology for a second. Hold on. I got to put you guys on this monitor and my paper on that monitor so then I can write stuff on it. There we go. All right. So on this first green graph, right? I think of this like little M&M somebody threw on the floor. Maybe I could draw a line like this. Do you guys see what I'm saying? You guys have seen stuff sort of like this before. I know you have, but this is the idea. So this is called either a trend. Jeff, you got to have an R in there. Trend line, or it's also called more officially, believe it or not, a line of best fit. Now think about that name for a minute. Why would we call it a line of best fit? If I try to, if somebody else, let me try to draw a line in this second dude. Why is this? Ooh, let me use a different color. Let's use green. Okay. Why is this a bad line of best fit? Why is that line bad?
It's outside of the other dots.
Yeah, so we, and I love doing this, so I haven't explained a damn thing. Oh, I'm so evil. But I want you to kind of tease out why it makes sense how we talk about these things. This is a bad line of best fit. What's good about it? What's one good thing about that line of best fit? What does that at least do?
It shows that there's a decrease.
Yes, is everybody with me? Before I drew the line, I could tell that the data seemed to be going down. As my X's go up, my outputs go down. Is that cool? It's got a negative slope to it. Are they perfectly lined up? These points. Obviously, do they all line up perfectly on a line?
No.
Hell no, right? But in real life, are things going to line up perfectly on a line, even if they're supposed to? No, of course not. When you have, some of you guys have kids, and did you know about the height and weight charts? I'm almost certain if you've had kids, you know about the height and weight charts. One of my friends, his kid, they named him Max, and it turned out he was like the 90th percentile height and the 90th percentile weight when he was a little kid. I'm like, you named that kid correctly. But you got the height and weight charts, right? If I have a kid, they don't have to follow that line perfectly. They could be a little below or a little above, but they should sort of follow that trend. Obviously, if I'm feeding them correctly and doing everything right, they should grow as they get older, unless they have some very rare condition. Okay, maybe. Are you guys semi with me? So even with something like how tall somebody is over the first 15 years of their life, you would expect that to go up. But for each person, they could be a little off from the general trend of things. That only makes sense. It depends on our genetics. It depends on our diet. It depends on the environment. It depends on a lot of different things. You guys with me a little bit? So even though this is not perfectly lined up, I would still say it's got a linear relationship. There is a trend that seems to be, and I can capture that trend better. Let me try a better line of best fit. Why is this better than the first one I drew?
It's within the data point.
Yeah, one thing is it's within the data points. I love it. Let me see if you guys are ready for this. I call this line of best fit, I call it the visual average. Become a G. Holy macaroni. All right. I normally write bad. I think it's the fact that today stuff is happening. Let me try this again. The visual average. Kick ass. Does that make sense? If I call that line the visual average, it tries to average out where all the points are. What is wrong with, so let me take that bad away because now I got a good one. Yeah, they're bad. What's kind of wrong with this, the yellow data back here?
No correlation.
Yeah, say it again, sorry.
There's like no correlation.
Ooh, that's a word I haven't used, I don't think. So there's this word she just said, correlation. I might have used it. I don't think I have. And that kicks so much ass. That's the idea behind what this is all about. How are two variables correlated? Which means if one variable increases, does the other variable increase by a roughly constant amount? This one, yeah, this one's really good. This one, yeah, that one's really good. This one, can you guys even see how to draw a line that would capture what this is doing? Maybe it's something like that, but whatever I draw, it's gonna suck so bad. Can somebody tell me why? Well, let's say that's the right answer. That's definitely not the right answer, by the way, but let me try to be a little bit better here. There, maybe that. Let's say that's the right answer. That's the best line you could draw. Why is that evidence that it really is bad, that it really doesn't have a trend? What's true about all the points versus all the points for these guys? Oh, I got a chat. I like that. Somebody's talking another beautiful word, outliers. There's more outliers here, meaning what? There are more data points that get what? What does outlier mean? I love all these words. What does outlier mean? Ooh. Yeah, an outlier. Has anybody never heard of the word outlier? Have you guys heard of the word outlier? No? So outlier, it's something that it's a data point that lies, that is very far away. It's very out there from the mean, from the average. Right? So on this data right here, if I had a point that was there, that would be a definite outlier. Why would this be an outlier? Because it doesn't follow what the other data does. This guy seems to have almost all of its data is outliers. They're all over the place. All right, let me stop for a minute. How you guys feeling about this so far? If you're probably a little freaked out about what is the homework going to look like for this. I understand. The homework is not going to be this freaky. So this is just the idea behind what we're going to do. All right. I love it. I love it. Okay. So let me go down a little bit. Now here's a real life example. What the hell does all this mean? So skin cancer mortality, and I'm really sorry that a lot of these are morbid when you talk about statistics. So basically the number of deaths per 10 million people and latitude at the center of your state, right? So is everybody aware that as you go up in latitude, that means you go further north? Can somebody that I haven't heard from yet tell me, let me let you absorb this. So this axis is deaths, basically. And this axis is how far above the equator you are. So the larger the number, the more north you are. So what is this really saying? Deaths are higher when you're in a state that is what? Deaths from skin cancer are higher when you're in a state that is what? When do they get higher, these deaths? When your state is?
Further from the equator?
Not further. When you get further from the equator, the deaths seem to go down.
Down,
right?
so closer.
Yeah, so if you're closer to, now why does that just make sense? Why should there be more skin cancer mortality, deaths from skin cancer, the closer you are to the equator? That only makes sense. More sun, that's crazy. That's crazy. Okay, I love you guys. Is everybody, and that's a little bit obvious, but it's still a really good example that you can hold on to. It makes sense. The results make sense. And then on this side, this is actually the equation. Don't worry about this too much yet. We'll get into this. But that line is the line of best fit for this data. So what good is that line? Everybody stay with me. So this line that was drawn by a computer, this line here, right? The line going, the little red line going through, is exactly what I was drawing on the last few pictures. And you're going to get to draw one of those yourself in a minute. What can I use that for? So let me write this equation better. What they discovered was the mortality, really the deaths, the equation would be 389.2 minus 5.98 times the latitude. Now, does that look like an equation we've created before ourselves? Do you guys see that? Can somebody tell me what, you ready for this? Can somebody tell me what the slope of this equation is? It's a little bit out of order, so be careful.
5.98.
Yeah, negative 5.98. So the slope, lowercase m, negative 5.98. So it's like mx plus b. I like it. You guys semi with me? So once I get that, I can say, well, I'm at a state. If I have a state, I'm in a state that's at, let's say, 45 degrees latitude. If I'm in a state that's at 45 degrees latitude and I want to see how many deaths per 10 million people are there from skin cancer in my state, I can plug a 45 in here. I can make a prediction using this line. All right, let me let all that sink in. All right, maybe. That's a lot going on. So what have we done before today? We have created lines, we've created equations, linear equations, given data. Have we not done that? We did the snow cone stuff. I can't even remember all the stuff we've done. We've made these equations given a bunch of data. Here is one more place where a linear equation comes from. It comes from trying to represent data that seems to follow a trend. What can I use it for? Well, what did we use lines that we created before for? We plugged points in to see what would happen in different situations. I could do the exact same thing with the line that we get from this. That's crazy. All right. By the way, why does it, this correlation, I would definitely call it a negative correlation. And it obviously shows up in the fact that the, oh shoot, I forgot I can't write out here. Negative correlation. And that obviously shows up with that being a negative slope. The slope is negative and it's a negative correlation. I love it. I love it. Okay, I think I have one more example real quick. This is another negative correlation. So this is as you get older, men, this is what your maximum heart rate does. So as you get older, your maximum heart rate goes down. Let me use my mouse. So there, blah, 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 blah. So this would obviously be, does this look like a strong correlation? Let me just throw this at you. Does this look like it lines up decently well? Especially compared to yellow measles up here, right? That didn't line up at all. How does this look? Does this look like it lines up pretty well?
Yes.
Maybe? Yes, a little bit. All right. Not perfectly. It's definitely not perfect, but it does line up pretty well. Pretend like I'm drawing a straight line. Okay. All right. And if I remember correctly, you can look this up, guys, if you don't believe me. I'm pretty sure that the maximum heart rate is roughly 220 minus your age. So like, for example, at 50, yep, it's 170, which is 220 minus 50. Do you guys see what I'm saying? Anybody? If I calculated this line of best fit, it would come out to be about this. The maximum heart rate is 220 minus your age. And I am approaching this point. Everybody is actually. I'm just closer to it. All right. All right. Maybe. So let's do this. I do want to show you one little thing, a little side note. This will be interesting. There are cases where things seem to be correlated. So for example, this is really weird. I just want to show you this. The amount of US crude oil imports from Norway versus drivers killed in a collision with a railway train, they seem to be correlated. Let's see, what else do I have? People who drowned after falling out of a fishing boat versus the marriage rate in Kentucky seem to kind of follow each other, right? But that's just how life works. You're going to find coincidences. So there's this whole website. I don't know if you guys can see the website name. It lists all these different correlations that exist. So if I see two things that are correlated, does that mean that one causes the other?
No.
No, of course not. Definitely with these. These are just silly. These are just complete coincidences. There's no reason to believe that if more people drown after falling, therefore, more people are going to get married in Kentucky. What is that about? Somebody drowned. How you feeling? Oh, let's get married. No, it's not going to happen, right? So I want you to realize there are studies that we do to look for correlations between different things. If we find one, that does not tell me that one of them actually affects the other one directly. I have to do further study to see if that's true. But something that does make sense that would be correlated would be, let me see, where do I want to go next? Yeah, let's go to the book. Let's go to the book. I want to do the book first, and then I want to unleash you on that thing that I asked you to print out. Let me stop sharing so I can recollect myself here. Here we go. So now let's actually see what some problems are going to look like. Because like I said, I can feel that you guys are like, what the hell am I going to have to do? Here we go. Bam. All right, here we go. Let me share this. Let's do this one together. This is on page 410 in the book. Oh, let me see. Managed. So is there a relationship between the total fat in a fast food burger and the total calories? So obviously, it should maybe make sense that what kind of relationship would there be? Would it be a positive trend? If the fat in a burger goes up, do you expect the calories to also go up?
Yes.
Yeah, that kind of makes sense because fat obviously has a lot of calories. If you cut down on the fat, you would expect the calories to possibly go down. Okay. So let's try to do this. So if you got your book, go ahead and do this. Go ahead and let's make this scatter plot. So I'm going to do this with you because you're going to have to do this. Well, you're not going to have to make a scatter plot, but you are going to have to do some stuff yourself. So let's see. I'm just going to go through each point here. So 9, 250 would be about right there, right? So everybody just do this with me. Here we go. 12, 290. 12, 290 is just under there. 8, 230 would be about right there. 12, 310. 17 is about right here. 470. 15, 310.
White Castle's the healthiest.
Yeah, where's White Castle? Oh yeah, look at that. I wonder which. Yeah, well, there's a little tiny. Aren't they little tiny burgers?
That's
White
why.
Castle. There you go. So you're gonna eat like 10 of these. No. All right, there.
There's soy burgers too.
Oh, soy burgers. That would help.
Oh,
Do
they
I have a
are?
Wait, what did I do? Not all of them, I don't think. But they do
soy
offer,
burgers?
do they offer some soy burgers, right? Not all of them are soy. I think that would trip people out. Are all of them soy?
He's destroyed my whole life.
Yeah, they're all soy. They're good, but they all soy burgers.
Oh, wow. I got to look that up. I had no idea. I love it. That is funny. You just destroyed Vu's world. Oh, man. Let's see.
Sorry,
19,
Vu.
A lot.
19,390. All right. So yours is going to look exactly like mine, but it should end up looking a little bit like mine. Let me make my points a little bit bigger. All right. So this step is pretty easy, right? Hopefully you guys agree. Just making a bunch of XY points. Oh, crap. What happened to you? Are you 2 points? I don't know. So here's what you're going to have to do in a minute by yourself. I'm going to purposefully, well, let's see. I pretty much gave that away, but let me see what happens. Let me change color here from my line of best fit. Let's do calming blue. Let me see if I can do this. Okay, I got a, all right, let me just kind of throw it on there and see what happens. You ready? Is that a good line of best fit? I like that. That's perfect. That's perfect. No, don't get me wrong. All right. Is that a good line of best fit? That blue line I just drew?
No.
All right, now somebody else tell me. Now think about it. Vu is correct. That is not a good line of best fit. Can somebody tell me why?
Because it needs to be within the points.
Yeah, so be more specific. So that is correct. So somebody else tell me, be a little more specific. It's got to be within the points. So what is directly, obviously wrong about this in terms of the points? Let me get a sentence started. There's more points. What's wrong about this line is when I drew it, there's more green dots. Oh, somebody's chatting at me. Above than below. It's not surrounded on the bottom. I like it. All right. That's all different ways to say that sucker missed the mark, right? Whenever you try to draw by hand a line of best fit, you're almost always going to have to do it at least twice. The first time you do it, you step back and you go, well, shit, that's not quite right. And then you adjust it. So let me do one that does run through the points. Let me see if I can do this. Here's one that does run through the points. Hold on, give me a minute. This is really weird to do this on this little weird pad I got. Well, that's still got the problem. Now, what's that guy's problem? This got too many points below it. Are you with me? I'm getting a little closer though, right? All right, let me try to do, here's my honest try. Let's see if Jeff can do a good one on purpose. All right, everybody, here we go. Let's see what happens. Let me try to map this out. All right, let's see what happens. I think I got a decent one. That one's definitely better. Does everybody agree with me? That one's better. It's probably not perfect, but it looks pretty good. I want to point out a couple things. Do you see how this point and that point are about the same distance away on both sides? Remember the graphical average idea, the points, it's supposed to average out where the points are. I still think it probably needs to go a little lower because see how there's more points further away on this side down there? Do you guys see that? But my God, if I'm going to do it by hand, that's not bad, right? I can live with that. I'm not going to do it again. I like it. I like it. Now watch. Now it's got some questions below here. Of course, I can't, with my technology, I can't scroll at the moment. So I'm going to just ask you these questions. Does the line I just drew actually go through any of the data points? It doesn't have to. Does this one happen to? It doesn't look like it, no. But now watch, here's what's important. If it did go through, I could just use that point. What I want to do right now is I want to find the equation of this line. What do I need to find the equation of this line? I need to see what? I need to see
The slope and a point.
true. In order to get the slope, I do need to have at least 2 points, right? So I need to find 2 points this goes through. Does everybody agree with me? Look at this one. Look how close it got to those points. It goes right there. What point is that? So my equation, my line goes through the point 12,300. Is everybody cool with that? Was that a data point? No. Does it matter? No, because right now I'm just trying to figure out the equation of the line I just drew. What other point does not my line go through? Let's see. Does it go anywhere? Let's see. Look at that. Look. Oh, look how excited I get.
About
I'm
7.
really excited now because do you guys see how it goes through this point right there? Right down here. Sorry. Can you see where I am? What's so beautiful about that? Well, what is that point first off?
The Y-intercept.
Holy shisa. That's right. So 0, 50. Why is that so beautiful to know the Y-intercept?
Because it's part of the equation.
Yeah, I can use the little equation now, right? Can I always use this equation directly? No, we did use it where we could solve for B, but now I know what B is. So like Vu said, the only thing I have left to do since I got some points is to figure out the slope. Go ahead and take a minute and figure out the slope between those 2 points. And remember, those 2 points we're using were not any of the data points. They don't have to be. It's just 2 points that the line you draw goes through. That's all they are. Because you're trying to find the equation of that line. And again, remember, if you really want to, you can label these points. So this will be x1, y1, and this will be x2, y2. And then it's really just throwing the numbers in the right place. So this will be 300 minus 50 over 12 minus 0. Right? So 250 divided by 12.
20.83 about.
Roughly 20.83. Okay,
Yeah, 3 repeats.
I got you. Now take a minute. Don't say anything. Did everybody get that okay? Anybody get a different answers? You guys good? All right. Take a minute and put the equation together. You know everything you need to know now to write the equation of the line. Don't say anything out loud. All right. What you got? Anybody? So now I got this guy up here. What goes there is going to be the slope, and what goes there is the y piece of the y-intercept. So it's going to be 20.83x. And then the y-intercept piece, the y piece is 50, so plus 50. Oh, geez, become a 3. There you go. Now, look through our data. Is there any data point that has 11 grams of fat? Any burger has 11 grams of fat. So what if we do go to a restaurant? Let's all go to Jeff's Burgers. It's right next to Bob's Burgers. And let's say I have you could get it out there, a hamburger that's got 11 grams of fat. I am definitely not making soy burgers. Sorry, White Castle. Can you predict how many calories it would have? How could I do that? Have we developed something that helps me take an input of fat and give me an output of calories? Have we created that somewhere?
Yes, in that equation.
Yeah, this equation. Right? Remember, X is grams of fat. That's the x-axis. X is grams of fat. So do I know what X is for Jeff's Burgers? What's the value of X for Jeff's Burgers?
11.
11. So now I can just, I have no idea why I'm yelling at you guys. Plug 11 in and see how this equation is now going to give me an estimate of the calories, because Y is the number of calories. Now, is this going to be exactly the right number of calories? Can somebody tell me, whatever number we get here, is it going to be exactly how many calories my burger has?
No.
Not necessarily, right? Because the line doesn't go through all the data points perfectly. But do I feel pretty good about this estimate? Would I feel pretty good about what this line does to make an estimate? I love this question. Was the line decently close to all the data points?
Yes.
Yes. So I'm going to feel pretty good. It's not going to be perfect, but what estimate is? So this is actually used in real life all the time. We take data, we create equations that model the data, and then we can use those equations to make predictions. It's insane. We use it all the time. Are they always linear? No, but let's just stick with linear right now. So what do you guys get when you do this in the old calculator?
279.
279?
Yeah, 0.13.
0.13? All right. I like it. And 11 is pretty close to 12, right? And we got 279.13, which kind of makes sense. 11 would be a little bit less than what we see for 12. So this kind of makes sense for the calories that my burgers would have, right? And of course, it depends on what other stuff you put on your burger. But here we're just talking about the burger, right? Okay. All right. So this is a beautiful example of statistics, a real life example of how to use equations of lines. And the way that we create the equation doesn't really change. It's just where we get the information from changes. All right, so now we're ready, I believe, for that handout that I asked you to print out. So is anybody still copying from this? Let me know. You guys okay? Can I shut that down? All right. I don't see anybody yelling at me. All right, here it goes. Bang. So let me open this up. So if you got that sheet, and this is what it looks like. It's up on Canvas. What I want you to do, right? There's no instructions here because I didn't want you to get too much of a head start. I want you to do exactly what we just did. I want you to draw a line and use the edge of a book, use the edge of paper, use a ruler if you got it, dang. Find some kind of a straight edge and draw the line in that best fits this data. And then try to figure out some points it goes through and figure out the lines equation. Oh, that's a lot to do. So let me know if you need some help. Let me know if you're not sure what you're supposed to be doing. Oh, that's true. Should I do that? Yeah, why not? All right. Start from the top. This is not the right answer, right? This is just my attempt, and I think it's okay. So I drew it a couple times. I kind of did it real light, and then I did it again, and it looks okay to me. This is not what you were supposed to get. Is everybody with me? Everybody got something a little different, and we're all fine because we're all doing it by hand. I got kind of lucky. I noticed it goes through this point. It didn't quite really go through that data point, really. But it did go through that data point, so I got kind of lucky. So it goes to the point 18.4. Is everybody with me? See how it's 3.5? So it's 18.4 and 12.10. Do you guys see how I got my points? Then you get the slope and you get you pick a point. I'm not going to show you all that work yet. I just want to make sure everybody's with me on the first step. And I'm sorry it's so shaky. Oh, well. This is why I'm not a YouTuber. Draw your line and then try to find a point that it definitely seems to go through, a definite point that it seems to go through. So yours might go right through like a point like right here, which is really nice. Or it might go through like mine did. It went right through a middle point. So I can see what point that is exactly, 12.10. It might go through a data point like mine did, which makes it easy. So the hardest part about this, I think, is once you draw it, trying to find a point that it definitely goes through. That's going to be the part that's a little bit difficult, but it almost doesn't matter because this is all by hand. So it's not going to be perfect.
I have a question.
Yes.
So to find the y-intercept, we can do the second equation we learned yesterday, right? That's designed for that?
Yeah,
or-
exactly.
Okay.
The y
just making
minus
sure.
y1, yeah, that's what I had to use. You could also, if you like it better, you could do the thing we did first, which was solve for b. Or you can use the y minus y1 business, right?
Okay. And so then in the equation, we get y equals something. The last one with the plus is the y-intercept, correct?
Kick ass.
Okay, let's make sure.
And then you can see if it makes sense. If I kept this thing going, I can see if my y-intercept makes sense. I can see kind of like where it's going. So if my y-intercept, if I got 17, well, that I did something wrong. Do you guys see that? So I should get something like 22 or something, or 21 point something. For my line, your line could be different. So can you do me a favor? If you've got your equation, can you type it in chat? So I'm going to type mine in. Here's what I got. I got really, really lucky. I got a really, really easy slope.
Jeff.
Yes.
So we're not picking the points that are on here. We're picking something that our line goes through.
Yeah. So see this point right here that I picked 1210 wasn't
you
a
didn't
data.
make it up, but okay.
Now I did get lucky. My line did go through a data point, so I could use that data point.
But it
You
doesn't
might
have to,
not have
right?
gone through a data point. Go ahead. Sorry.
It doesn't have to go through a data point because my line
No.
didn't go. Okay.
It doesn't have to. No.
Okay.
Tanya, is that, look at your, yeah, okay, okay. I was gonna say, maybe you did it like this, I don't know. Then it would be a positive slope. But don't do it like that. Don't freak out, everybody. Nobody's written the right answer yet. Trust me. Because the right answer is something like negative 0.8723x plus 21.784. Ain't nobody gonna get that. Are you kidding me? All right. So let me help everybody out a little bit. So what I did, once you identify 2 points that your line goes through, right? Once you identify those 2 points, it could be a data point. It doesn't have to be a data point like that one was for me there. Then you throw them in your slope equation, right? And it obviously should be a negative slope. So if you don't get a negative slope, that's a big, big problem. So I happen to get lucky. I didn't try to make this happen. I just try to let whatever happen, happen. And I happened to get lucky. Got a nice integer slope. You're not necessarily going to get an integer slope, and I'm really, really sorry if you don't. Then you just throw what you know. If you get a decimal, all right, that sucks a little bit. But oh well, you just put it right here. And then you put your point in the y piece and the x piece. You can pick either one of these 2 points that you got. Right? Doesn't matter which point you pick. So let me see. I'm getting some more stuff. Dude, Vu, wow. Vu is going for most decimal places. That kicks ass. I like it. No, it's perfect, Dan. I'm not, please understand. I love that. That's awesome. And let me tell you, my answer is further away than most of your answers is from the right answer. So I'm loving it. You guys are doing better than I do. Would anyone like to see what the exact right answer is? No, you guys don't care?
Yeah.
All right, let me show you. Here's what it looks like graphed out. All right, you ready? Here's the exact equation. So basically negative 0.88x. So negative 0.88 is the correct slope if I round it. So see, I was pretty far off from that.
I was close. I got negative
Yeah,
0.833333.
kick ass. But some of you guys are going to be below this. Some of you guys are going to be above this. I was -1, so I'm below that. Plus 20.49, so like 20 and a half should be your Y-intercept. Please don't feel bad if you got way far off from that. Right? This is not like an easy thing to do by hand. Aubrey, how's Aubrey doing? Yeah, look at Aubrey, dude. Angeline was pretty close too. Yeah, I think Aubrey and Angeline were like on either side of the right slope. Vu wins for most decimal places. All right, all right. Sorry that I don't have any gifts to give out. You get recognition. So let's come back to this real quick. So now what I could do, and everybody, I didn't really point this out. Hopefully you guys really paid attention to what this is all about. This is hours studied versus mistakes made. So thankfully, the more hours you study correlates with less mistakes made. Now, it seems to make sense in this case that the hours studied should affect the mistakes made, right? That does make sense, but I can't make that assumption. But I can do this. What if I were to study for, now what's really, really funny is notice how I could possibly get negative mistakes made if I study for a long time, right? So that's not going to work. So it only works within the data. So could I, if I use the right answer, which was negative 0.88x, if I remember correctly, plus 20.5. Could I predict how many mistakes I would make if I studied for 15 hours? Right, that's just like the problem we did earlier. So if I study for 15 hours, how many mistakes can I expect to make? How would I do that?
X with 15.
Yeah, exactly. Just put a 15 in for X. So Y equals negative 0.88 times 15 plus 20.5, and you know, whatever the hell that is. Let's see. Did I do that right? I wasn't even looking when I did that. Let's see. Yeah, so I expect about 7.3 mistakes. I love that. So roughly about 7 mistakes. Let's see if that works. 15 hours is right here, and that comes out to be right about 7 mistakes on my line. That's pretty close to what I said too. Are you guys rough? Are you guys with me out there? This is like everything we've done together in a real life context. This is what happens in real life statistical analyses. But like I said, there are some correlations that would be, what would it be if it was like this? Does anyone know what kind of correlation this would be? I don't even know if you can see my points. If I had data points that were like this.
And a curve, was it U-curve? No, bell curve. What's the opposite of bell curve?
Not a bell curve, but a
Parabolic.
It'd be quadratic. So this would actually be energy consumption throughout the year. So you have the summer, then you have the winter, I'm sorry, the spring and fall, and then you have the winter. So this could model, and of course, if you do it for over the course of several years, it would go like that, right? Energy consumption. So there are things in real life that follow this curviness. That is more complicated math, right? Of course. Lines are much easier math. Curvy stuff, much more complicated math, but the same exact idea. Okay. Woo! That was pretty good.
So would it be correct to say there's a direct correlation? Is that the right language for studying and amount of study and mistakes?
Yeah, there seems to be, from those numbers that I made up, I like this, I'm going to teach with my hands now. For those numbers that I made up, there seems to be a correlation. But you have to understand that I'd have to do more. That's a little too close in person. I have to do more studies to actually see if there's one that causes the other one. So I could do a study about people that take a certain kind of pain medicine and how they feel, the correlation, but I'd have to do a study where I give people different amounts of the pain medicine and some people don't get the pain medicine. That would be to see the cause. This kind of study is just to see if there's a relationship. And sometimes the relationship is coincidental. Sometimes, now watch, listen to this. It is true that if teacher salaries go up, the sale of booze goes up. Did you guys know that? This is a true fact. Does that mean that all teachers are slushes? No. What happens if teacher salaries goes up? What more than likely happens also?
And everybody else's stuff is going up.
Yeah, a lot of other people's salaries probably also went up, right? But you don't know how close to truth that is. Yeah, trust me, kids. Sometimes it helps, but don't go too overboard. Have fun, but be careful. All right. Anyway, sorry. Oh my God. What are you doing to me, Sam? Is Sam trying to drive me to drink? Is that what the point of this is? I don't know. Okay. All right. I think that's enough for today. We did plenty. I love that section because it brings everything together and then there's a real life application. I think that's enough. So if you look at the homework, it's not gonna ask you to do a lot of what I did. A lot of what I did was conceptual stuff, just getting the idea down, right? So take a look and then let me know if you have questions. And again, the quiz is moved to Monday. It's not gonna be this Thursday. It's gonna be Monday. It's gonna be 3-4 through 3-7. Okay, that's it. Let me know if you need to hang out. I don't know if you guys
Thank you,
noticed
Professor.
we had a visitor earlier. That was my dean. My dean was here to watch me teach. Yay. And that's the last thing. Now I could be an asshole because all the people have watched me. And you can do nothing. No. All right, guys. Anybody have a question? You guys good? All right, get out there and
Having
vote.
to study at 12, right?
Yeah, I've got my office hours, 12:30 to 1:30. Yes. I'll be there.
Thank you, Professor. Have a good day.
You're welcome. See you guys.